Jai Hind and good morning to everyone. My name is Vikash Kumar. I am Assistant Professor in Mechanical Engineering Department at Akgec Garg Engineering College. In this semester, I am teaching Automation and Robotics. Subject code is BOE 303 and same subject students are learning during their fourth semester with code BOE 402. So, during this, I have gone through various topics while I am teaching this syllabus. And today I am going to cover some extra topic, like first topic that I am going to cover is robot mastering. So importance of robot mastering is very essential, because while you are operating any industrial robot, sometimes you have to do this mastering things so that your robot can act perfectly as per your requirement, as per your programming coordinate. So moving ahead with this topic. So these are the 5 operations that I have described here. If you want to configure your robot or plan your robot for any application, you have to know about jogging so that you can jog your robot. You should know about robot safety so that you can safely operate your robot. Third operation that we have to perform is mastering. Mastering is basically you are going to give some reference, through that it is going to take their coordinates. And fourth operation that is very important is tool calibration, and the fifth one is base calibration. These two calibrations are required with different tools and different workbenches. So talking more about all these 5, these are the very essential and important operations that you have to perform if you want to run your industrial robot as per your requirement. So today I am just going to cover this mastering thing in more detail. So talking more about mastering. So first we have to understand what is mastering. So mastering is a process that assigns the reference value. Means if I am talking about industrial robot, it is having 6 degree of freedom for particular articulated robot. So this articulated robot, suppose 6 axes are there. So how this 6 axis is going to move as per your defined coordinate, that depends upon this reference value. So more precisely, if we have to define industrial robot, so industrial robot mastering. So mastering is the process of identifying the geometrical parameters of an industrial robot, such as the relative position and its joints. So this is the basic definition of robot mastering, why we are going to do. And you have to understand difference between mechanical zero position and home position. So for each and every industrial robot, there is a defined mechanical zero position. For this particular articulated robot, axis 1 is having 0 degree position, axis 2 is having -90, axis 3 is planned at +90 degree, and 4, 5, 6 axis is planned at 0 degree. So this is the mechanical zero position that is mechanically defined on the robot structure. For particular one robot, only one mechanical zero position can be defined. But if we have to talk about this home position, so there is a very small difference between mechanical zero position and home position of the robot. While we are talking about mechanical zero, only and only one mechanical zero position possible in any mechanical structure of the robot. But if we talk about this home position kind of thing, so it can be n, means it can vary from 1 to as per your requirement. So with one industrial robot, I can define n numbers of home position. See, just I am drawing one application. Suppose this is my industrial robot having pick and place operation, and here suppose one table is there. I have to place something that is coming through conveyor. So this is like our conveyor, on that this part is coming. So robot will go from this home position to this, and from this to this. So travel is very smooth, means robot is going to go from their home position to, suppose this is P1, and from P2 to table position, that is P2 coordinate. So here very smooth transition of motion you can see here. So this is home position 1, suppose, in another case, suppose my table is here. So, this is suppose table 1 and this is table 2. And suppose I have to perform operation where conveyor is at same position here. From here, and I have to place my part at table number 2. So, how it will going to happen? So, from home position 1, it is easily go to this P1 and then this P1 it is coming through this way, long way. So, overall cycle time it is going to increase. So, we always have to minimize this cycle time. So, how we can minimize? Suppose instead of table here, if we are going to place conveyor here, conveyor table here and part is coming at this end. So, this robot we can define or we can reorient in this way so that the cycle time from here to here can be minimized. So, from here it is going to pick their part from the conveyor and place it here. So, in this example we have gone through like this is one home position that can be defined, this is second home position. So, what understanding you have to take from this slide for if we are talking about mechanical zero, so only and only one mechanical zero position can be possible with one single robot, but if we are going with this home positions, so it can be possible as per user requirement and it can vary from 1 to infinity. You can define n numbers of home position in your robot. So, coming back to our original topic, why this mastering is important, why we are doing this mastering. So, basically mastering always perform to fix your robot at their mechanical zero position. So, here earlier we have defined for this particular articulated robot, suppose these are the values where our mechanical zero is declared. So, we have to do mastering considering this mechanical zero position, so that your robot can be having one reference, through that it can go with some reference. So, here some mastering why we should go with some mastering things, when suppose I am having one mastered robot, but there are some cases in which I can lose the mastering of my robot. So, what are those conditions where mastering can be compromised? So, going one by one, during startup of the robot, suppose you are relocating your robot from one place to another place, your robot has to be mastered again, because it is going to forget their reference position. Second, mastering when any maintenance work, any component, suppose you are releasing or you are taking out from the robot and putting new component. So, during maintenance we have to replace some part. So, in that case also you have to do mastering again, because suppose you are replacing only one single motor out of 6 servo motors. So, the reference value that is earlier saved in their encoder can be compromised. So, you have to do again this mastering thing for whole axis. Now, third case is movement of axis without controller. During some accident, suppose power supply is not there. After accident, suppose you want to move your robot manually. So, there is a some arrangement through ratchet, you can move your robot by putting one lever on the center axis of the motor. But in such case, basically you are moving your robot manually, so it will also going to lose their mastering. Now, coming to the fourth case, mechanical repair or problem. Suppose again it is like maintenance only. Suppose you are doing any maintenance work, but not related to motor, but related to some other part. Suppose you are changing the belt that is in between two gears. So, the tension of that belt, some in past it is having some value, but in present suppose you are replacing with some another belt. So, it is having some another value, another tension value. So, in that case also some mechanical repair work you can lose your mastering. So, let us see how we can perform mastering step by step. So, the very first thing that you have to do, you have to operate your robot only in teaching position, in teaching mode, that is T1 mode, and you will find these white marks, different white marks are there in relative axis, like this is for axis 1, and if you observe this thing, if you observe this is a notch having V groove shape, and here in this lever we have pin. So this notch and pin having some white mark, so you have to pre-master your robot, means each and every axis should be like move in such a manner it will come together, it should align. And second case, after pre-mastering position, you can just open this cap, you have to open this cap, and you have to apply mastering tool. So here you can see this is a mastering tool that we are applying here. So in robot mastering case, we have 2-3 options how we can master robots. So I am having this dial gauge. With the help of this dial gauge also, like here you can see thread portion is there and one pin is there. So inside one pin is there, that is going to fix at this notch. So with the help of this dial gauge, manual dial gauge also, we can fix our mastering thing, but here lot of experience required. If you want to do it electronically, you have again 2 options, like this is EMD and EMT tool. So in this figure you can relate this same tool I am having in my hand. So this is electronic measuring device. After like opening this cap, I can put this device here, and this device also having one pin. So what is going to happen here? So this is this lever pin, and this notch is already presented at the robot end. So while I am moving my axis at very slow motion, suppose this is V groove and this is coming from here to here. So this pin will go inside this notch perfectly. In this case, if you observe, this red dot shows the actual mastering position. So here it is happened actually. So this is the way, like after putting this lever EMD tool, we have to slowly move robot on this plane surface. After that it will go in the falling edge. At one time it will go in the falling edge, this edge, and at same time after some time it will achieve this mastering position, and again it will going to start at rising edge. So here rising edge, you can see this is rising edge, this is falling edge, and this is the perfect position where exactly we want to master our robot. So with the help of all these tools, either by this EMD or this dial gauge, we can master our robot. And if you observe, this is another device that we have to like carry with us, because it is having some port. If you observe here, so we are having some wire like this is the wire that we have to put here, and another end we have to put in robot RDC, resolver digital controller end. So it is going to transfer all these values to their respective motors encoder. So it will save the reference value, that is our mechanical zero position. So this device and this device combinedly we have to use if we are trying to master our robot. And this device also having some light arrangement, so that I will show you in next slide. So this I have covered, like we can master our robot with the help of dial gauge or with the help of electronic measuring tool, or this is another like way in that you can also master your robot if you are having your previous data. If you are having your robot data backup, also you can like install those data in your current robot, it will resume all the readings. So this is the suppose our target value where we want to apply mastering thing. So these are our mechanical zero position for each and every axis. This notch is present at robot end, and this EMT or dial gauge we have to apply, and we have to move slowly from this flat surface, and we have to go there at the peak of this notch. So these are the pictorial view, like this is the mastering kit. I have shown you this EMT, EMD. This is the like encoder things that we have to carry with this dial gauges and other things. So these are the dial gauge. This is manual operation, through that we can master our robot. So for each and every axis we have to revise this exercise, like mastering always have to perform from axis 1, then 2, then 3, then 4, then 5, then 6, like that. So we have to go in sequence. So we cannot go like that, so we have mastered axis 1, then we can master for 4. So we have to go sequentially. So there is options that you will get axis 1, axis 2, axis 3, axis 4, axis 5. So one by one you are going to master your robot, and this is the exact position that you have to achieve during your mastering. So this is a mechanical 0 written here at the down, mechanical 0, where your pin is going to perfectly fit at this notch. So if that is going to happen, means our device will show the switching of this. This red light means you are at flat edge. So here it is red. Now second means it is falling edge. Second, this is second means your notch is at the falling edge. And when this second to 3, it is going to switch from second to 3, means here somewhere we have achieved this perfect like alignment of the notch. So you have to identify, or you have to take care of these lights. If it is switching from second to third, means just at that moment you have to stop your like robot movement, and you have to press master device kind of thing. So you have to push master on the teach pendant. In this teach pendant, suppose if you are doing mastering, so down you will find some master option. At that moment you have to press master device. So it will save that particular axis data. And as I said, this exercise we have did for first axis. Similarly we have to do for second, like that up to 6 axis we have to do similar kind of exercises. And after this, suppose I am going to ask this question just to knowledge check, like here you can find 1, 2, 3, 4, 5 options are there in this figure. So identify the mechanical 0 point of the axis in a given image. Suppose you have to identify where is the exact mechanical 0. So which number you will select? So you can go with 1, 2, 3, 4, 5, but only one option is correct. So as we discussed, if our robot pin or notch going to meet at this point, so this point is basically our axis, our option 4. So if you are saying fourth option, so that means you are correct at your part. This is the exact mechanical 0 position that we have to achieve. So similar pin, similar notch arrangement you will find with each and every axis. Suppose you are handling articulated robot, so it will be articulated robot. There you have to manage 6 axis. If you are doing with SCARA, so there you can manage 4 or 3 axis, like that. Different robot having different joint configuration, but you have to take care of all these in similar way. So this is all from mastering side. So if you have any doubt, thank you.